Video 4, question 71, the maximum value of 8 minus 10 sin x cos x. Now the moment you see the expression sin x cos x next to one another, one possibility is to consider the identity 2 sin x cos x is equal to sine of 2x. That's exactly what we will do here. And also we're going to write this as if it is a function. So we're going to write y is 8 minus 10 sin x cos x. And then we're going to manipulate it slightly in order to use the given identity. And we're going to write it as follows. Y is 8 minus 5 times 2, which is 10 sin x cos x. And there you have the expression that you're looking for. So this is exactly what we wanted to do. In brackets, you have 2 sin x cos x, which is equal to sine of 2x. It's much easier to work with this in terms of functions. You then have 8 minus 5, and in brackets, you can write that as sine of 2x. If you consider this as a graph, the y equals 8 minus 5 sine 2x, we're going to start by making it a little bit easier for us. We're first just going to look at minus 5 sine 2x. And once we've sketched the graph minus 5 sine 2x, we then simply add the positive 8, which is going to be a vertical shift to the graph. Alright, so the graph minus 5 sine 2x would be a graph that would look like that. It would have a maximum value of 5. It would have a minimum value of minus 5. And all we do now, we simply add the positive 8. And that would be, as I said, a vertical shift. So the positive 8 representing a vertical shift to the graph. And if you shift this graph by 8 units upwards, you're then going to have a maximum value of not of 5, but of 13. And that would be the maximum value of the expression. Alright, let's move on to the next question. This is also a graph-related question. And you can see here that it talks about the derivative of f, given the graph of the derivative of f. And so we're clearly looking here at gradient. Remember, the graph that you see here isn't the graph of f, it's the graph of the derivative of f. And so if you consider the word derivative, let's quickly look at the two parts of this graph. The first very important part is the part that sits above the x-axis. And the part that sits above the x-axis is where the x values are less than negative 2/3. So let's just stop there for a moment. Where x is less than minus 2/3, the derivative is above the x-axis. In other words, it is positive. Alright, so the graph of f would have a positive gradient. F has a positive gradient. I'm just going to abbreviate it. Where f has a positive gradient where x is less than minus 2/3. Look at the graph. Alright, so that means that the graph increases to the left. The graph of f increases to the left of minus 2/3. And there sits your answer.